for attending this AIML workshop. We have familiar names from last evening's workshop. I think, yeah, yesterday's workshop. So glad to see you guys here again. Okay, thank you, Jared. This is noted. So I'll make this quick. Again, there will be a post-event survey form that will be sent out after this event. If you answer that, you get the Easter. Clap, clap. And just a few words from the co-lead. He really asked me to share this to you guys because why not? So he says here, this is Jay. He's my co-lead. Thank you so much for coming to next event. I hope you all learn something and listen attentively because knowledge is adjacent to power. If there's anything you should take away from the tutorial, it's to probably do it yourself at some point because practice makes something, and that something is up to you to determine. Enjoy your easy days for those in San Carlos and the workshop. Big ups to Nick, me, Jared, and the marketing team, and blah 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 for making this tutorial a reality. I shall be there in spirit. Be on the lookout for more stuff from us because this is only the beginning. Okay, whatever he says. So yeah, guys, that's a message from. He really begged me to send that. So there's that. As for me, I'll keep it simple. Sit back, relax, pay attention, follow if you can, and yeah, I'll give this one to Nick. Nick, do your magic. Hello.
Hello, hello. Okay.
Yep.
Thank you for those kind words, Homer. It's really sweet. Also from our other lead that is here in spirit. So that means look behind you guys. He might be actually just beside you, looking over at your monitor. So um, here it's presented on screen. Of course, is the GitHub repo. So I encourage you to open it and maybe browse through the code because we will be referencing it a lot. And also in the repo, you also have a short guide on how to set up your accounts for GCP and AWS. So as I mentioned earlier, and also as Homer mentioned earlier as well, that I won't really be giving you like an in-depth tutorial on how to create your account because well GCP, if I log out of GCP, I will get logged out, I will be logged out of Meet as well for some reason. And for AWS, I don't have a different email address for account setup. But I'll just show you like basically what website, what link you have to go in order to sign up for your accounts. And so I'm gonna switch screens. Is it working? I think it's working. And so for AWS, you just have to go to AWS, Amazon.com, and /console. And for GAP, just enter this link, which is HTTPS colon double forward slashes then console.cloudgoogle.com. So basically, if you're creating a new account in AWS, you just click create account, write your email address that you're going to use, and your account name. So it will ask to verify your email address, then it will also ask for your billing information. So yes, both GCP and AWS, even if you are using the free tier, it will still ask for your billing information. So that requires a debit card, credit card, or you could use like Gcash if you're a Gcash card or whatever. You have to put your information in order to be able to create an account in the first place. So I'm just gonna sign in to my AWS account. I'm gonna exit this one. And go to sign in using your email address. And I'm just gonna enter my credentials in front of you guys. Okay, that's good. And here we are. So make sure that we are on the same region. So for now, we're gonna be on US East 1 because it's overall the cheapest like region that you could run your resource on. And for GCP, I don't think it matters at all. So that's it for your account setup. And now that's just really it. I hope you guys have completed your account setup already, like beforehand, before joining this workshop. Now we're going to go immediately to the notebook setup. So, but before that, I'm just gonna give you like a brief, like what is this for? Like, what's the vision here? Like, why are we doing this? So, for some tasks, right? For some AI training tasks, you can't really just sometimes we do discover that our resources are not enough. Like our PC is so slow, or laptop might be, you might even have just a ThinkPad, or you don't have a laptop at all. You don't have a PC. You only have like a mobile device. So even if you have a mobile device, because of cloud, you can access GPU. Is provided by cloud providers like AWS or GCP. So the purpose of this like workshop is so that you guys can or learn how to use this cloud resources, because surprisingly, or not really surprisingly, but um I think it's, for me, this is my opinion, but you can ignore my opinion, but it's unfortunate that a lot of students opt to buy an entire GPU for their thesis. So you don't have to buy like, I don't know, like an RTX 30, I don't know, whatever, or RTX 40 series just to do your thesis. That's very expensive in today's what do you call this, landscape. Plus, it's actually worse. So I'll tell you a story, huh? So I have this friend who asked me that she wanted me to help her out with her thesis, and so it was an large language model fine tuning, and the GPU they used was a 4060. Well, it's not the best, but it's still a 40 series GPU. So they use this GPU. So imagine you have in this training or in this fine tuning setup, you have 3,000 steps. Sorry, 2,000 steps. They had 2,000 steps for the setup. For each step, it would take 9 hours to complete. 9 hours for one step. Imagine 2,000 steps. That would take you months, right? And not only this, for like even like classical machine learning setups where you just train like, um, for example, an LSTM model. It I have a different friend who actually took 3 weeks to train their model. So with cloud resources, that would actually go uh, go down to even hours. So 3 hours. So that's what happened with my friend's thesis, is that we brought her months training setup to 3 hours. So we completed that fine tuning of her large language model, 8 billion model. Sorry, 15 billion model in under 3 hours. Completed the fine tuning under 3 hours. So this is a really good, and that only costed like what, 300, 500 pesos. In the landscape of, or in a big picture as a thesis, that's really, really, really cheap. Conferences could cost 20K. So for you guys, it might be very worth it compared to just buying a new GPU altogether. So let's start with the notebook setups. So in particular, we're gonna be using Jupyter notebooks that are hosted on AWS and GCP. So um, there are very very specific products. I think that's what they call it, products for AWS and also for GCP. So for AWS, you have your Amazon SageMaker, and for GCP, you have Vertex AI. And so that as an intro to using AI in the cloud, I think it's better to use what we are familiar with, which are Jupyter notebooks. But it's not really the most efficient way to go about it, but it's a good start. And so let's start on AWS. Okay. Oh, AWS. And so on AWS, you just go to your console home and you just literally search SageMaker. So click the first thing that shows up. And then because I've already set up mine, I think this should show a different uh, menu. I should say set up for single user use, and you should just click that one. So for me, it's get started because I already created mine. So it should bring you to this, what do you call this? This menu or this link. And so in SageMaker, notebooks are wrapped in what are called like studios. So in studios, you just don't only have like notebooks, you also have different features aside from Jupyter notebooks. So, but for now, we're gonna be only using Jupyter notebooks for this demonstration. And so you go to your left panel here and you click SageMaker Studio. So since I've already created mine, it should say create new studio. But um, I think that should be the thing that shows up on your icon, on your interface. So since I've already created one, I'm just going to open the studio. Uh, could you raise your hand if there's something wrong on your side or if like there's an issue? I think so far it's just fine. Okay, so I'm gonna open the studio and I'm gonna click launch personal studio. But yeah, whatever uh like prompts that showed up on your device, you should reach this looking page wherever. So looking at a feature on the left side of application, you actually have like a lot of features here. This is code editor, so this is like literally I think this is just VS Code on the cloud. You have R Studio, you like R, and you have ML Flow for like building your machine learning pipelines. But today we're going to just create a Jupyter lab space. So in order to create this Jupyter lab space, you just click create Jupyter lab space, make it private, and then put whatever name you want. I'll just put AI on the cloud and create space. So this is going to be creating our space. There we go. And so for this demonstration, we're gonna use ML.T3 large. So this is like one of their let's say intro level instances that is offered by AWS. But of course, if you are running very heavy workloads, you could pick their any GPUs here. Just look at or GPUs or CPUs. Just look at you can read about the information about these instances by looking up AWS SageMaker instances. I'll show that later. For now, since we're gonna be doing a simple task, we're going to be picking ML.T3 large. So we're gonna click run space. Mm, okay, I don't. Okay, this just doing the creation. So starting the space. So now, while this is running in the background, we're gonna create, we're gonna go to Google Cloud. So, it's different on Google Cloud because on AWS you don't have to create like this things called like there's like workspaces and they're called projects in Google. On AWS you don't have to do that, but on Google you have to create a workspace in order to like run everything that you want. So we're gonna open. You're gonna click the project picker just to the right of the Google Cloud logo, and then let's create a new project. So let's name it whatever you want. I'm just gonna call this AI on the cloud. So just put no organization and then click create. So it's loading and boom. And then you click, go to your notification here. You could click select project, or you could just go here to the project picker, select AI on the cloud. So we're here. So you can see we are in the project. And so what we're gonna search in order to have this equivalent like uh, space for Jupyter Lab, you're gonna search workbench. The first thing should pop up, workbench, and it has to be this one under Vertex AI. Not the one under healthcare, but the one under Vertex AI. So you click that, it's gonna do a lot of stuff. It's gonna ask for billing accounts. Click my billing account, set account. Oh wow. So I've reached the limit. So I'm just gonna you shouldn't have this error. So what I'm gonna do is delete one of my projects. So there's a lot of projects I have. I think you don't have to do this, but I have to do this because I have a bunch of projects. Someone did raise their hands. With oh, stream is gone. Okay, my bad. Yeah, just inform me that happens because I think there's a running problem with my device. I don't know why that happens, but I guess it happens. So I'm just gonna delete a bunch of projects. Hang on, guys. Mm, okay, I'm just not gonna delete. I'm just gonna go to one of my projects that I already made. So I'm here in tests. So we're gonna go to workbench, Vertex AI, and then we're gonna go into here notebooks on workbench. This weird like I don't know. It looks like the stealth startup logo if you have seen that before. So under notebooks, right? Click that, um, and then we're gonna create a new Jupyter Lab instance. So just click create new, and it's up to you which zone you want to use in which region. You could pick one near the Philippines, but that also comes with increased costs. So it's usually like for just oh, is it gone again? What's that? Just for like projects that involve like does not involve like has to be responsive under like a millisecond. It's- you can use like regions near you, but for this we're just training right an AI model, so we're just gonna pick central one, which should have the cheapest resources out of all the regions. And so here it should tell you what's the estimated cost. For now, we're not going to use a T4 GPU because that is very overpowered for this kind of project. You can if you want to, but for this project, we're just going to unattach that one. So you have advanced options. then with advanced options, you can select which machine type you have, and they do have description there and what CPU platform it is. So for this, just we're gonna use E2. You can look into the other stuff here, but um, as like an introduction, we don't need to do. We don't need to go into the specifics. So while that's creating, we can go back. I'm gonna exit this out, and I'm gonna exit this one. So let's refresh the SageMaker Studio. Mm, okay, so it's already running, as you can see here. And just click open Jupyter Lab. And mine, the pop-up is blocked. I don't know for you guys, but if the pop-up is blocked, just allow the pop-up. So while mine is loading, let's take a bit. Um, we can go to Google Cloud. Oh, it's still also creating. Yeah. Oh, I started. That's good. Let's say no here. So this is what you are greeted with. And so for our demonstration, we're just literally going to git clone the GitHub repo that I showed you guys earlier with the QR code. So let's go to the terminal here and other. You could also go to the terminal by going here, file, new, the terminal. But sorry. So now we're going to git clone my uh, GitHub repo that I showed earlier. Okay. So it should show up on the left. Uh, is this too small, guys? Should I zoom in? I remember how to zoom in my.
It's all good, Nick. All good.
Okay. Fidelity just died. Okay. So we're going to go to one of our sample notebooks. So we're going to notebook. Yeah, the root folder in the cloud. They go to notebook and then open example project. So this example project is gonna ask for the kernel and just click on ipykernel. Select. Also, we're gonna open a new terminal as well because we have to install the requirements as well. So I actually did not put. So we're gonna write the requirements file in. So what we're gonna do is just manually install the packages, which is fun. So pip install and like gboost, optona, numpy, what else? Plotly, scikit-learn. I think that's it. Oh, I see more as well. Oh wow, it's already satisfied. That's great. And so, um, if you're familiar with Jupyter Notebooks, they should be very familiar with you. And if you've been to our second session of the AIML webinar series, this project should be familiar with you. So what is this project? So it's essentially um, a model that is made or is trained to predict how fast the delivery time of a certain restaurant is. Also, it's up to you. You could also determine like what's the average from exploratory data analysis, how far the customers are usually at, how frequent are your orders, or how much do the customers order. But for today, what we're gonna do is just try to predict how fast the delivery time is. So you can do this with your own project, your own project right now. Just run your own project. For this demonstration, we'll just run all the cells. And maybe, I think we still have a lot of time. I'll just go through this project just in case you might be interested. But this is a really simple project with only like five, how many rows? There's 8 rows. So this is like a dummy project, but it is like an interesting, or interesting or fun introduction into data science or AI in general. So I'm not gonna run through that. I'm just gonna go through our exploratory data analysis. So we're gonna run this cell, and this loads. There we go. And so from this plot, let's try to determine like how much. Oh my god, my answer. Oh well. Let's try to determine how much like items do the customers order. And so from this plot, no, um, as you can see, I mean, just reading the output here, or just looking at the histogram at the back, you can kind of determine that usually you customers order about 2 items. So like if you go to Jollibee, you want to buy Jollibee online, or from Food Panda, you buy 2-piece fried chicken and then chicken macaroni soup or whatever you want. Maybe that's what the customers usually order. So um, we're gonna run a heat map here. So the purpose of this heat map is just to show the relationships between our variables. So okay, so our Z, sorry, uh, your sorry, your Z axis here is the average order size, um, which is literally the right one here, the the color bar, as you can see. Your
Nick, your
X,
screen again.
oh, it's gone again. Okay. So your X axis is the oh, the Y is the weather conditions here, and your X axis is the traffic conditions. So basically, the darker the color is, the more trafficy, or like how heavy the traffic is essentially. And so, hello.
It's good, all good, all good, Nick. Continue.
Oh, just someone left.
Somebody
Okay,
joined.
okay. Oh, okay, my bad. Okay. So from this plot, oh my god, from this plot you can determine, and when it's foggy, there's a lot of traffic, and also when it's uh raining. Oh, my bad. So orders are high. Oh, sorry. The colors determine. So my bad, guys. So colors determine how much the customer orders, and the numbers at the bottom tell you how heavy the traffic is. So interestingly, for some reason, on a cloudy weather and heavy traffic, a lot of people order because it's about to rain, it's traffic. Why would you go out, drive your car, and go to a restaurant, right? So that's why people, for me, that's for me as well. If it's cloudy, I don't go out. But it's heavy traffic, so I just order from Food Panda. So let's go to our next heat map. Um, I load, and here we are. So the relationships here are different now. So you have your weather conditions again for Y, X for your traffic conditions, 3.5 being the craziest traffic, and Z, the color, is basically how long it would take to deliver. It's 35 minutes, longest, the earliest would be 15 minutes. So obviously, on a day of heavy traffic and it's foggy, you have your, oh, sorry, when it's heavy traffic, you have cloudy, it takes the longest time to deliver your food. There's no like data for rainy and heavy traffic. That's why there's no color in these like boxes, as you could say. So we're not gonna run the baseline model because the baseline model is not as good as our proposed model. So proposed model is the XGBoost, stream grading boosting, which is literally just a really, really good model overall, which you can use in a lot of types of problems, classification, um, multi-classification, and regression. It's very like all around. So that's why you could say that your baseline model is a linear regression, but at the same time, you could also say your baseline model should be XGBoost or something like that. So we're just gonna run these. Oh my god, forgot we have to run everything here. This one, and let's run this. So the columns. Now we're gonna do fine tuning. So this is the fine tuning we're gonna use here is actually from a library called Optina. So this fine tuning is actually called parse entry. And it's a kind of fine tuning that uses Bayesian optimization. So it doesn't say, but by default, it uses Bayesian optimization. There's also other types of optimizations, but for this case, we're going to be using Bayesian optimization. And so here, parse entry, that's the spelling. And so in order to, you know, this was a question that when I was still first like getting to AI, like because you don't define the hyperparameters of your model, right? So usually when you're running a model, you don't have this here. You can actually just use, the default parameters, hyperparameters, and you get your result. Then good luck. I hope it's good. But usually, if your assumptions are good, um, and your data is good, especially, you don't really need to tune the hyperparameters. But in this case, we're gonna tune our hyperparameters just for the sake of demonstration. So we're gonna define how the fine tuning would work, and we're gonna run the study. And it's doing it right now. So this is not an error, guys. This is just how it works. And so it was able to find the best parameters really quickly. So for big like projects or big models, big data, this might take quite a lot of time. But luckily in our case, this took rather quick. So usually, no, um, the best time or the best use cases for using your what do you call this? Your AI, your cloud resources is best for um, deep learning situations because those use like a lot of resources. For classical machine learning, you can just do it on your any laptop, any device, and it would just run and train rather quickly. But in one such case where you don't have any like PC devices, you just have a let's say an iPad or tablet, you can actually train an AI on the cloud on your tablet. So like if you're going to a hackathon and you don't want to, I don't know, you don't want to bring a laptop for some reason. I don't know why, but let's say I don't know, you forgot about it. There's a one way to use cloud resources to train your artificial intelligence model. So we're gonna check the performance of the model. Um, with what we're doing here is regression. And when you take the RMSE of your regression model, the units is not a percent, of course, it's in minutes. So since we're trying to determine how long it would usually take for an order to arrive, of course, the unit would be in minutes. So your error would also be in minutes. So this is just saying that the model has an error of 10.31 minutes. So it could like predict or over under predict, like let's say your order arrives in 12:30, you ordered on let's say 12:10, your order might arrive 12:40 or 12:20. That's what it means. So this is checking for feature importance. We're not going to go through this because it's not really part of this demonstration. Now we're going to do the same on Vertex AI. So now if you refresh, you have a check mark. It means it's active. That means we can finally use this model. Sorry. And so wait for this to load. GCP usually takes a bit of time. And so what we're gonna do here, okay, it's already good. Never mind, we're not gonna wait. And so just ignore the multitudes of errors here, whatever. You don't need data proc. You don't need whatever resource managed API they have here. You can look into that, but for this demonstration, you don't need it. So just the same situation. This is literally just Jupyter Notebook again. So there's nothing special. So just a like quick run through. We're just gonna literally repeat what we did earlier. And I'm not gonna. I'm just gonna go. I'm gonna glaze through this really quickly because um we already did it earlier. Yeah. Mhm, mhm, mhm. What we're gonna do is select Python 3, IPy So what you can actually do in order to like not run the code manually each cell is just click. Oh, okay, it's ready. So it's just click the double what do you call this? Fast forward play button in order to run your entire notebook. I'm sure you already know that, but that's what we're gonna do here. And oh, it actually doesn't have. So apparently GCP you still have to manually install some of the what they call this, some of the libraries. Mm, let's hope it has everything. Just drink water if you're thirsty. Always never forget to hydrate. So this should work now. And we're gonna click this. And it should, yep, starting and it's executing the cells. Boom, boom, really quick. and it's done. So quick. Uh, these kinds of like work, uh, these kinds of like tasks on the cloud because you're using like resources that are dedicated for these kinds of tasks where you're when you're doing it locally, your device has to, also deal with your OS and everything else, like whatever tabs you have in the background. But if you have, of course, if you have cloud resources, everything is purpose built for everything you do on on Jupyter Lab. So I'm gonna maybe do a brief run through to the feature importance. So there are a lot of feature importance. There's a lot of ways to determine your feature importance, but um, for XGBoost, or rather, yeah, for XGBoost, you have your built-in like importance, like feature importance. What do you call this? Parameter or feature importance values, and that's what we're trying. That's what we're calling here. And from this bar graph, you can see that usually if the restaurant is far, it would take longer. I would that would be no, sorry. If your restaurant is far, um, usually that's the reason why your order would take long. So and also your restaurant popularity for this particular data set, of course. So sometimes you in order to improve your performance of your model, if you're trying to like put it on an edge device, or you just want to cut the fluff or like trim the fat out of the like your model, um what you could do is determine which features are not useful and just basically remove them. In this case, we could just actually use the distance feature and then the restaurant popularity feature. And that's what essentially we're doing here at step 4, where we're only using the order size and the weather, sorry, the weather conditions and the traffic conditions. And so, sorry, we're dropping we're dropping these columns and then only using restaurant popularity and your distance to your restaurant. So if you look, scroll down, your performance improved by 0.01 minute. So for this case, it's not really that useful, but this is just for demonstration purposes. In your case, it might be or your problem, your thesis or your project feature importance might actually help. And you have k-fold validation here, which you can run after. Is it gone again? Oh, my bad. So, which you can run to validate whether your uh, your performance is not because of random chance. Because sometimes the shuffling that occurs when you are splitting your data set is up to like you're actually lucky that uh you got like the just right amount or just the right kind of splitting that your model is performing really well. And apparently after shuffling it a couple of more times and running training and inference and validation testing on those 5 like shuffles, we were able to determine that actually the average error is 7 minutes. So if you order 12:10 and estimated time of variable is 12:30, you might actually either arrive like around 12:37 or 12:23. So that's basically it for Jupyter Lab now and Workbench for Vertex. Oh, sorry, that's basically it for SageMaker and Vertex AI. So it's kind of short, but you know, looking at looking at time still 8:59. So I thought that we should go beyond what I'm showing you right now. This is we just still have an hour to go. So before we go to the next section, let's most importantly uh, kill our resources or uh, delete our resources. Because if you don't, you're literally gonna have runaway resources and you're gonna be spending like 5K by the end of the month if you don't stop your resources or kill the resources. So let's exit the Jupyter Labs notebooks. And for SageMaker, we're going to click stop space. And for Google Cloud, you click on the check mark and you click delete. Loading, stopping. Mm, okay, good. Stop na siya. Um, or Vertex AI, it's still stopping. So let's go to SageMaker. So we're not done here actually. So um, yes. Sign out. And we're going to delete our domain. So you go to domains, the left hand side where they have a list, and you click the domains, essentially its name. Still in service though. So you actually cannot delete the domain for now because you can see this is grayed out. So by reading this like description, the domain must not contain any user profiles or spaces. So what we're gonna do is going to go to user profiles, and then we're going to click the user profile. Remember, going back here, go to user profile, click your user profile, and you're gonna click delete. Yes, then delete. So just wait. Um, Ignore this. Since this is currently deleting, we can go here and oh, look. As you can see, the instance in GCP is already deleted. So now what we're going to do is actually let's not delete this yet. Um, in GCP, if you're done with your project, usually what you do is delete the project, which is in your actually not here. Yeah, you go to project picker. For now, well, let's not delete it yet. Let's wait for Amazon to finish the deletion. So hang on. What is this thing? It's showing. Hang on. It should be showing. I think I really can delete it. guess you can't delete the user. Yeah, there's still a space. So you go to your space and click delete. Okay, so deleting. There you go. Then we're going to delete this user profile. Delete, yes, delete user. Delete. It's been deleted successfully. Now you scroll down here, your domain settings. You can finally delete your domain. Which is good. So now, in those cases, no, the cons in like, what is displaying? The cons in using the Jupyter Lab instances is that if you literally exit out of that page from your browser or something, it will actually, yes, the training would still be running in the background, but the problem would be is that you can't interact with the notebook anymore. So TLDR, you lose your progress, or you just lose your whatever you're doing in your notebook. So that is a problem that is inherent to Jupyter notebooks. There's on the in the case with SageMaker and GCP, there's no like way around it really. So for cases where you are training a big model, let's say like my friend, she was fine tuning a large language model, or you are training a deep neural network, you have to rely on get virtual machines. So this is like the next I'm sorry. This is the next half of this workshop where we're gonna try to create virtual machines and use spot instances. So in both in GCP and AWS, you have something called spot instances. So spot instances are like instances that are cheaper, up to 90% cheaper. So the disadvantage of using spot instances is literally in the middle of your training. Um, it just like it's like a borrowed instance good. So like it's like someone's using that instance, like I don't know, like in someone in the world's using the instances, but it's currently like stopped. So what we're doing is just like literally borrowing that while it's stopped. So that's why it's cheap. At the same time, if they do start the instance, it will literally kick you out of the instance. So that's why I'm just telling you that thing exists, but usually if you're training a big model, no, you have to use your Guan. You have to use like the normal instances. So I think this is deleted now. I'm still deleting. Oh, okay. Good. It's deleted. So we're gonna go back to the front page of AWS. And before we go to EC2, which is basically the product that AWS has for creating virtual machines, and the equivalent here on GCP is just literally called, I don't think it's here on the website, but it's just literally called VM or virtual machines. So going back to EC2, so um before we launch an instance, I just want you guys to be aware of quotas. So you service quotas in particular. So in AWS, you don't have direct access. So if you make a new account, you don't have direct access or immediate access to all the instances that AWS have or has, um, because they're basically locked behind this like uh, locked behind permissions, and you have to request access to it in order to use their big beefy GPUs. So we're not gonna request a quota, a service quota, but I'm just gonna show you guys that this you have to request you really have to request service quotas when you're training big models. So here we're gonna look type EC2, don't click auto scaling, click the second one, which is Amazon Elastic Compute Cloud. So click view quotas. And so usually, these are my suggestions, is that you use G instances, not the spot instances, but G, G, where is it? It's G6. There we go. Oh, it's not even dedicated. Anyway, guys. Um, hang on, let me look it up. I forgot the specific name of Dakota. But for instance, no, if you're using like spot instances, which I mentioned earlier, gets like reclaimed by whoever is using it. You click here on your G and VT spot instance requests, which I suggest is like a good middle ground for uh price to performance. Here, the P5 and the other stuff here is very like crazy na siyang it's like business requirements for training whatever. They I think they provide you like 192 gigabytes of RAM. And in this like landscape, no, where RAM is super expensive, it's kind of a lot, and it's probably like worth like, I don't know worth more than the GDP of the Philippines. And so here currently my applied account level quota value is 0. So usually for any like spot instance or any instance requests, it's usually when you're requesting values, it has to be in terms multiples of 4. So 4, 8, 16, 32. And so how do you determine what number to put in? So let me open up uh, the AWS website. Uh, hang on. If I could put it. Oh, oh my God. What's going on here? Stream. Asa, is this working? There we go. So you go here to this link, AWS Amazon, AWS, Amazon.com, EC2 instance types. You go to pricing, on-demand pricing. And wait for this to load. And you pick here accelerated computing. You search G6. So whatever like GPU you want to use. So the G6 instances are very powerful. Huh? So on like retail, these cost like 1 million pesos. So if you want this amount of performance, you have to like fork out 1 million pesos if you have one. But you don't have 1 million pesos, um, you can actually just rent their GPUs. And so these are the specifications. So if you want to use like, for example, 16 gigabyte 16 gigabytes, if your model needs 16 gigabytes, usually for large language models, you need 32 or more. For like basic like I think 15 billion model for Olama requires like 23. So usually the minimum you use the G6.2X large, and your VCB level would be 8. And so going back here, I think it's on demand. Aha, there we go. So the quota is called running on demand and G and VT instances. You also have your quota code, which you can actually, if you're using CLI, you can use this and just enter the code into the CLI. And so again, request account, I request increase the account level, and at the minimum, just request 8. And they usually give it out even to like new accounts, like a day or two after, and then you'll just have access on your GPU. So I remember here the pricing is like quite expensive. Um, if you're running this, if you have a model that's really big, I mean, in the bigger picture, when you're doing your thesis again, this kind of cost is nothing compared to whatever else you have to pay for. I mean, here in San Carlos, um, the conferences are very expensive, and they don't allow you. I believe they don't allow you to pick research conferences that are hosted in the school. So you have to pick an international conference here. And that would cost, even if it's just like remote, that would cost you upwards to 20K. But you also have like other, like book binding is very expensive. So again, my point here is that this might look big, but this is nothing compared to your overall thesis expenses. And way cheaper than buying a GPU by itself. Is it gone? Thank you. Uh, share window. Share this window. So let's say you have already requested. Is it work? It's working. Let's say you've already requested a quota increase, and you have now 8 quotas for G and VT instances. So for EC2, Amazon's on GCP is really just rather simple. I think you just literally pick out which one you want. I could be wrong, but they tell you from this interface how much these instances cost. On AWS, it's more secret to figure that out yourself. So that's why on AWS, you have to be a bit more responsible on how you deal with your costs. And so what we're gonna do is launch a simple instance. Um, I hope we could run our my code for actually an iris dataset training and evaluation. So we're gonna click launch instances and name it whatever you want. AI on the cloud. We call it AI on the cloud. So usually I suggest you browse your AMIs and you click deep learning. Um, search. There we go. So Amazon has like these like AMIs. So AMIs are basically like OS or like just a setup na OS for your whatever your task is. So sorry for usually for me, I use deep learning, the OSS driver, NVIDIA driver for PyTorch. So you can scroll through here. You can look into the descriptions if you really want the very specific notes. You can just copy the actually it doesn't work there. You copy the AMI, look it up, and look into the details. So we're gonna do is just pick this one for x86, the deep learning OS NVIDIA driver, GPU for PyTorch 2.9 and Ubuntu 24.04. Pick that. Oh, okay. So I think we don't need to do the key pair thing because what we're gonna use is the AWS built-in CLI. But for demonstration purposes, that's grade one. So AI, I'm gonna call this AI on the cloud for key pair and downloads it. But in our case, we're not gonna really need that. But let's just put it there for keepsakes and go or for demonstration. So usually, I think by default you can use the large models. I believe. Um, so we can use this one. But for demonstration lang, no? We're gonna use the micro, uh, the micro or the medium model na lang guro. So it's like the same as what we had earlier. Actually, since we're using a bigger one, let's try X large. So I scroll down, create security group, just pick allow SSH from anywhere. Um, this isn't really required for our case, but just have it there. So for your storage, 100 gigabytes, I think 50 would actually be just fine. 50 gigabytes, and that's it. So if you click this, it will just create another volume. Just leave it be with the default settings because you don't really need more than this. So you have your advanced details under here. If you, as I've said earlier, if you want to use spot instances, you can go to um where is it? Should spot here. Oh, there we go. I'm blind. You go to spot instances. You click this, and you can ignore these settings here. But one of the more important one, aside from your pricing, whatever, is the behavior. So when it hibernates and when it shuts down, click stop and click uh actually ignore this one. Make sure that your shutdown behavior is not terminate. Because what would happen if it's on terminate? Every time someone, as stated earlier, like uses their instance again, like because since you borrowed this instance and they want to reclaim it, every time that happens, it will literally delete your instance or terminate your instance. So I think it's prudent to just use stop. But in our case, we're not going to use spot instances. Overall, I think it's better to use mm, dedicated, uh, or rather on-demand instances. So here you have actually a run script. This is called user data, but this is actually the you could actually use this to enter like your startup scripts, so you don't have to like um do the get clones or whatever. It does it automatically. But we're not gonna fill this up for now. So review. Okay, yourself. So just click launch instance. Well, really quick. Okay, that should be running. Now let's go to GCP. So as you can see here, you have your cost estimates. So it does give you like some description, um, like what it's really good for or whatever. Um, just look into the performance of these like what do you call this? These instances, and see if it's enough for your use case. So as I said earlier, um, for most tasks in AWS, you should use G6. But here, it's a bit more like, what do you call this? I wouldn't say vague, but um, it's there's more like types to pick from. I say. So like even from the same CPU platforms, you have like uh different instance types. Um, for here, you have, of course, for even for AMD Turin, you have different like pricing levels, let's say. And so for now, we're gonna go back to the instance that we've launched here in AWS. So gonna click on it, and you can follow these instructions if you want to use SSH. But in our case, we're going to use um, the EC2 serial console. So you can see there is an error. This account is not used authorized to use the EC2 serial console. So we're gonna click manage access, click allow, update, and then go back to instances, click your instance, click connect. Oh no, my IP. Ooh, but you don't have my, what do you call that? Uh, key. So no worries. Oh wow, apparently it's not loud. Oh well. So we're gonna use um EC2 instance connect instead. So connect using my well, I'm gonna use my public IP. Click connect. Establishing the connection. Boom, you're in. So same process. We're gonna git clone my repo. Um, github.com gd.ac. AI on the cloud. Git clone cd AI on the cloud ls. So for this case though, we're going to completely be using the CLI. So please don't be afraid. Don't, you know, react in horror, despair, and depression. Because if you just at the end you have to put your training, or like compact, or like package your like notebook into a script. Because for the point of a notebook is just for prototyping, for testing, or for visualization. If you really actually want to train a real model, and why would you use a notebook when you already know um what kind of model you have to use, what kind of like um pipeline, like what the parameters are there for the splitting, whatever. You have your If you're gonna be using your notebook and you're not gonna be changing it every time you train, every time you try to train, what's the point of using a notebook when you just put it on a script in a script? And so for we're gonna try to run this, but it might not work. But um, we're gonna try nonetheless. So we are in Iris. So if you have been to the AIX Cloud Chain, cloud, not Cloud Chain, blockchain event by what do you call this? By DevCon last November 29, November 30. So we had an event, and I did this basically run down of PyTorch, and the code here is literally the same, or I'm just reusing what we use during that event. And so you can look this up on my GitHub. This particular event, it's very interesting. Um, was very very fun event. I'll be honest. There was a lot of attendees, and overall, the reception was really surprising because the entire room was filled. So it should be here in. If you go to GDGOC AIX blockchain, this is the repo for that particular event. So that's not the topic. Basically, giving you a rundown of this task, I did was just um, train a convolutional neural network for the iris dataset. Oh, sorry, it's linear. A deep neural network for the iris dataset. And I compared what happens if you don't shuffle your dataset, and if um, you don't compare it against a test data. So here, um, what happened here was that, sorry. So what happened here was the accuracy was very horrible, because the problem was that initially we didn't shuffle it. And that's basically it. Can go through this. So what I've done here is a repo that I posted at the beginning of this workshop. Is I just literally like package it inside a Python script. So let's run the script. Check our version. It's a Python 3. That's for Python 3. Wait, did I put this? Yeah, Python 3. And run. Clean that. Whoa. Actually, I think we need to chmod plus x, train that time. And we're gonna run. I think it might crash the instance, but this is currently the best instance we can have without requesting service quotas. And we don't have a module name torch. So that's weird because we're using PyTorch. Oh my god. Hmm. What I did here is just literally install pip and wait for this to finish. Uh, oh my god, really? Oh, it disappeared again. Thank you. Um, well, it's giving there. I think we have to create a virtual environment, but I think um it's gonna take too much time now. Usually when you're using a really like kuana, like a instance that is kanang let's say big or like heavy, just like the G6 instances I said earlier, you shouldn't have these problems. But what we're gonna do is just try to create a virtual environment. Oh, that's not really the point of this demonstration because what we've already like done is just created the virtual machine, which is basically after that it's completely up to you and how to create your or like how to run your training or whatever for your own purposes. Oh, I hope. But still have time, so I'm just gonna do it. Uh, okay. What I did there is just create a virtual environment um, by running, how do you call this? Creating the directory, the VNV, invoking the VNV function or the virtual environment function on the directory, and then, oh, sorry, this one. And then we're gonna install Torch. It's just gonna take a bit of time. Disclaimer, uh, disclaimer, so like, yeah, wait for a bit, drink water, whatever. Eat if you have not eaten, have not ate. So I think what's happening here is that since we're using a CPU instance, uh, even though it already had that PyTorch OSS, the video deep learning, no, na AMI that we used earlier, we're currently not using a NVIDIA or NVIDIA like device. So what it's doing here, I think it's installing the torch for CPU instances. I think CP means CPU. Essentially, that's literally how you create your ano, create a virtual machine on AWS. And here on GCP, we're just literally going to pick, let's say, AMD Turin. For flexible and cost performance, we're gonna pick for vCPU 16 GB memory, standard. Here you have spot. Here you can check the monthly estimate or the hourly estimate. So we're gonna create this. Wait for that to start. Okay. So download the torch. Let's try to run the uh, the file. Oh, okay. So seeing check mark your instance is running. Could use SSH, or what we could also use is what we are already using is the SSH connect. Oh no, not that one. Sorry. The drop down and then open a browser window. And for some reason, it's opening a different one. Oh my god. My credentials. Okay, we're in. So same what do you call this? Same process as earlier. Let's actually check if it has torch. No module in torch. Again, we still have to install everything manually. Okay. So let's exit out of this client here. So same here, we're gonna exit here because we're running out of time. So maybe in another workshop, we're gonna go into the nitty-gritty of training using virtual machines. But basically the main point of this workshop is just using the Jupyter Labs to train your own AI models. So go back here to instance details, or you could just click EC2 here again. Uh, Actually, you have to look that up there. My bookmarks. Click search EC2, or could have it here. So now what we're gonna do is to clean up the instances. So always clean your instances or like delete your instances so that you don't have runaway costs. Don't be surprised by the end of the month you have $100 bill. No. So go here to instance state, click the instance state and click terminate and terminate. So it's initiated termination. It's going to delete this instance. Now same here, click the check mark and go to more more actions and click delete and click delete. So all that's happening, let's review if this actually deleted. Oh, refresh. Oh, it's still shutting down. As for GDP is also still deleting. So while we still have time, I'm going to show you one resource um, that you could uh, use for quick like creation of these like instances or whatever. So in cloud, this is streaming the rate. So we're gonna go to AI on the cloud and then go to deployment. Here, there there's a link to Terraform. So Terraform is this like I want to say it's a programming language, but it is like um a tool so that you won't have to use your uh you won't have to use the console. You don't have to use the website. You can just use
Nick, your
this.
screen.
This oh, it's gone. Okay. No, no, no. So yeah, it's just a tool so that you don't have to open your AWS or GCP console. You can just use the CLI tool so that
It's
you
gone
can
again.
just oh, it's gone again.
I think it's killing like I don't know, man.
I think it's like
The
I don't know,
resource
like
management, like memory.
Mac OS resource management. I have a feeling that's the reason. But yeah, go to like the installation, just install it on your own like what
Yeah,
do you
it's
call
gone
this
again, man.
device. Oh, it's gone again.
Yeah.
Uh, oh, not
Try
this
using another
window.
browser or something.
Maybe it's a Safari thing. I don't know. Safari is very dramatic. But yeah, this might be on a future workshop. But I'm just putting this out there so that you could have like an idea of what Terraform is, or like at least you know of its existence. So this just automatically this code here is automatically like um creates your resources on AWS or your respective like cloud provider with your specific specific settings for like your VPC or SSH or whatever. So that's just about it for Terraform. And going back to oh, it's gone again. I saw that one. I don't know why it's doing this now. It's almost ending na sa Atom event. But yeah, just sharing. And it's terminated. That's good. And going back to volumes, currently have no volumes, which means that it has deleted the respective root volume of your instance here in AWS. And also going back to your Google Cloud GCP, go to VM instances. It's also deleted, which is very good. So let's delete this project. So I could copy this ID. Go. You basically go to the project picker, click the manage resources page, click your particular project, go to delete, and then oh wow, write our project ID here. What was it? 17 E7 shut down anyway. Oh, and it's gone, which is good. So it's clean now, and your AWS is also clean. So yeah, that's just about it, guys. Although the gist of this workshop um was really all about SageMaker and Vertex AI. but I thought it was nice if I added, a run through an overview of virtual machines for both GCP and AWS. And so yeah, that's it. If you have questions, ask them now. Oh, true.
Yep. Go ahead, guys. Just use the Q&A tool, and I'll read them aloud. And I'll just read your name because I believe the comments are off. So just please do use the Q&A tool. You should see a circle square or a square a square made out of circles. There's a bottom right and just Q&A. Just press Q&A. Yep. It's gonna be an interesting workshop. That was a lot. If you also feel that way, don't worry. There's gonna be a video that will be uploaded to our YouTube channel. So it's a video on demand. It's a VOD, so you are free to repeat certain parts that might have been clear, and like stuff you can do with video that you aren't able when you're live. Yeah, guys, questions are welcomed and encouraged. People who ask will get their answers earlier. Massive.
Oh my god. You guys
Are
have
you
t-shirts.
eating? What are you eating? I hear
They're
eating
eating
ASMR.
Jollibee.
Damn.
Really good. I
Hmm.
was craving Jollibee earlier. But yeah. So like, guys, if you have questions, just ask them now. But all the resources that was used in this workshop are just in the repo. The link to the Google slide is also in the repo if you are interested in this like Google slide. It's basically just a bunch of uh headings. But yeah.
I think I have a question ish, but this is more of a discussion. What was like aside from your friend asking you for help for her thesis, were you already familiar with cloud tools like this prior to that? Like, were you already messing around with
Mm, yeah. So I think my first full year or first like
Fourier
end of let's
transform?
call it
Eh,
location for. Oh yeah, my first endeavor endeavor into like cloud tools was back in 2024.
hmm,
I think before that I had like some knowledge, but using SageMaker was around 2024 because I had to perform like inferences on a edge device, and of course you can run an entire what do you call it, a CNN model on an edge
hmm,
device because it's too big. So that's why I had to use cloud resources.
interesting. Was there like a criteria for that? Like, oh, when should I consider using a cloud platform?
Mm,
Or are there
I
times
think.
where that is overkill?
Oh yeah, I think you just have to like test it out, like at the bare minimum. Like you start at the bare minimum, and if that does not work, upgrade, upgrade, upgrade. So of course, for edge devices, I think it's generally just better to use if you're using like large lang or like deep learning models. Of course, you have to use like Cloud Good, unless you're using the NVIDIA's like forgot they have these like edge devices
Mm,
that are built
special na.
for large language models. Yeah.
So rarely does anybody have that. Okay, I think that's all for me. Anybody else would like to, we can end early kayo. Okay, sakto lang. An hour and 53 minutes. So again, guys, I'd like to remind that we will be sending out survey forms after this event. Please do answer because it helps us improve. Yep. We again highly appreciate your attendance and yeah, just for being here. Nick is very happy, right, Nick?
Yeah. Although my throat is like dry from all the coughing.
Yep. Sige, I'll do the countdown. Going once, going twice. Are we good? We good, guys? We good? Can I get heart reactions at least? Any form of reactions? One, okay. Okay. Excited mo sa Easter's. Okay, understandable,
Guys,
understandable. But hopefully, yeah, the knowledge is the most important part, guys.
guys, pwede rin naman doktor ng inserts.
Yeah, I believe that's it. We good. Thank you so much, guys. Again, I don't think I can add anything from that other than that. Stay tuned for more. Question mark, Nick. Anything you
Yes.
might expect from the one in person?
Another in-person
Who
event.
knows, you know?
Finally. We're
In
out of the
person event.
COVID, like, we're out of the
We're out of
COVID,
the,
like,
out of the COVID setup.
landscape.
Yeah, but
Yeah.
yeah, guys, we're all good. You may now, but we're gonna chill here for a few more minutes. You guys wanna chat, but yeah, we're officially adjourned, quote unquote, as they would say. Thank you so much. Yeah, I'm gonna stay
Bye,
here for a while.
guys. Take care. Good night. Good
Um,
night.
yep. Thank you, Jeremy.